Let's see an example where decoders are very useful. They are frequently used for selecting one out of many possible circuits. Okay, so basically the outputs of the decoder are connected to enable inputs of one of many units, and so the corresponding unit is enabled, only one of the units is enabled and propagated. So an example is address decoding for memory blocks. Okay, suppose you are given an address, let's say a 4-bit address, and depending on the value of this address, you're required to read the memory contents at that address. So if you have 4-bit address, then you have, let's say you have 16 registers, R0 to R15, and depending on the value of the address, that particular register is to be read. For let's say if the address is 0010, then we want to read R2. Okay, how do we implement this? We just pass the 4-bit address to a 4x16 line decoder, and each of the 16 outputs of this decoder are connected to the enable inputs of these registers. Okay, so for any input combination, only one of those enable lines is asserted, and that particular register can be read. Or all of these may be connected to a common bus, and only that particular register will be asserted and will be read. Okay, so this is a common example where decoders are used. Let's see the exercise for today's lab session. You are asked to build a 3 to 8 line decoder with an enable input. Okay, so the decoder needs to have this interface. It needs to have a single 3-bit input X and outputs D0 to D7. So X and D could be implemented as a standard logic vector, X being 3 down to 0 and D being standard logic vector 7 down to 0. Okay, so you have to write this entity description, and for this entity you're supposed to write two architectures. One is a structural style architecture using basic AND or AND NOT gates as components, and the second one is a data flow style description using concurrent, conditional or selected signal assignment statements. Okay, then you are asked to write an appropriate test bench that tests each of these architectures for all input combinations and submit this code in a single file. So here is the second question for this lab exercise. What we have is a combinational circuit with a 3-bit input X. Okay, of sorry, there is a typo here. This is correct. It's no typo. So we have a 3-bit input of type standard logic vector 2 down to 0. Okay, and this combinational circuit has 4 outputs: F0, F1, F2 and F3, such that F0 is 1 only when the input is all zeros, so only for the combination 0 0 0. F1 is 1 only when the input is an even number or a multiple of 3, when interpreted as a unsigned binary number. F2 is 1 only when the input is greater than or equal to 6, that means it's greater than or equal to 110. And F3 is 1 only when the input contains an odd number of ones in its binary representation. Okay, so you are asked to implement this circuit by using a 3 to 8 line decoder as a component. So you are asked to find the Boolean expressions for each of the outputs as a sum of minterms, then use a 3 to 8 line decoder and all together the corresponding minterms to generate each of these outputs. Okay, You are also asked to write a test bench for this circuit that will test all input combinations and submit this code as a single file with this name. So that's it for Lab 5.